Hi, everyone. My name is Andriana, and I'm marketing specialist at Intellias. Today, we met here to discuss our JavaScript topic. And before we will start our event, and while others are joining in, I would like to talk a little bit about Intellias. So Intellias is a trusted technology partner for top-tier organizations with all over 3,200 professionals on board. We combine engineering, craftsmanship, and technology expertise to solve challenges of any nature, scale, and complexity. We create complex software solutions and work on innovative products for Fortune 50 companies. Our development centers are located all over the world, welcoming talents from Europe, Asia, North and South America. Our offices are located in particular in Ukraine, Poland, Colombia, Bulgaria, Spain, Portugal, India, and Colombia. I'll share a link to our career website, and you can check it in. Maybe a career match will happen. Thank you for everyone who joined us. Today we will have a very interesting topic, and Mikita host will help us to present it. Before I'll give a word to our speaker, I'd like to talk about a few technical moments. First of all, you have an open chat where you can send your questions during the presentation. And in the end of presentation, we will sound these questions and Mikita will answer them. Tomorrow or later today, we will send you a letter with a link to the recording of the event and as well a presentation that will be shared today. By the way, we would kindly ask you to fill in a feedback form that will be attached to a letter so we can improve our events and we will take into account all your comments and all the things that you will fill in. So thank you for everyone who joined in. Mikita, stage is yours.
Yeah, thank you very much. So yeah, thank you everyone for joining, and just give me a sec. Let me share my screen and show you the presentation. So yeah, we can get started. So yeah, again, thank you all for joining. And before we get started, just a few words about me. So let me introduce myself. My name is Mikita. I'm principal JS developer at Intellias. I have more than 10 years of experience working on projects of different sizes, from huge enterprises to small startups. Also, I'm Intellias Center of Excellence expert, tech speaker, and also I'm a PhD in startup lifecycle management. So my main technology stack includes for the front end React, Angular, and the rest of this zoo of front end frameworks and libraries. For the backend, I work mostly on Node.js with different libraries and frameworks like Loopback, Nest.js, that's my framework of choice, and so on. Also, I use Golang sometimes. For the mobile, I have experience with React Native. Currently, I'm interested in Flutter. And in terms of some DevOps stuff, I've been working with AWS, Azure, Versal, CircleCI, and others. Yeah, I've been working in different domains like fintech, telecom, trading, e-com, automotive, restaurants, hotels, IT cloud, and others. So I believe we can finally get started. So what I would like to talk with you about. So first when we talk about the microfrontends, the idea here is it's not always ideally clear for people when and why they need it. Well, comparing if we were talking, let's say, about the performance optimization, yeah, in front-end application, that's quite simple. So when we need to optimize performance, when we have some issues with performance, that doesn't work that simple with the micro front-end. So we'll need to talk about theoretical aspects a bit. So we'll talk about the front-end application lifecycle and which problems we have in terms of these theoretical parts. After that, I'll provide you a very close to real-life example where we can discover all these phases and analyze them. After that, we'll talk about the actual disadvantages. We'll try to sum up the front-end application lifecycle and their problems and go to disadvantages of the monolithic front ends. After that, we'll start actually talking about the micro front ends themselves, how they can help you, what is actually a micro front end. We'll talk about the architectural rules and requirements which we have when we work with micro front ends. And we will just deep dive into the libraries and frameworks which allow us building rich micro front-end architecture. And after that, we'll talk about the most challenging situations with the micro front-ends. Let's call them pitfalls. And after that, I prepared 3 sample projects for you guys. One is written in React, one is in Angular, and one is, let's say, framework agnostic. It's single SP. Well, you'll see. And at the end, we at Intellis prepared our own insight of the internal project refactoring using the micro frontends. And when we finish all this practical and theoretical part, we'll talk about that from the business perspective. Yeah, we'll try to analyze and to sum up everything, how exactly it can help your business, your team, and in other words, how you can pursue your team, your client, your business to invest in micro frontends. And at the end, yeah, I'll try to answer all your questions. So yeah, let's get started. So I believe you all been there when the client comes to you and saying like, hey guys, I have a business, like, let's make it rock. I need this and this and this. And after that, there are more and more and more features. So we are releasing more functionality. And at the end, situation changes. Yeah. So we're getting slow. The customer is unhappy. He's starting to ask us, hey guys, you were so cool at the beginning and now you are so slow and there is so many bugs in production. So what's wrong? And it's quite understandable situation. So let's try to take a look at this situation in terms of life cycle, yeah, and in terms of the phases when the situation happens. So how usually it works, we'll try to take a look at the average front-end application lifecycle. Yeah? So when the client comes to you, usually clients has some idea of some features for the business, yeah, and we start the MVP phase. So what is actually an MVP phase? It's a sort of advanced proof of concept, yeah. So we just need to deliver something to the client to show ourselves like an experienced team, experienced developer, and to allow the customer to understand the potential of this project. Yeah, so we are doing some heavy coding, we're designing infrastructuring, and so on. And usually at this phase, we should not care about the project future, about the clean code very much, and so on. Yeah, I mean, for sure, we don't need to write bad code, but that's not our main priority at this phase. Yeah, and what is really important here is business is not yet ready to invest a bunch of money in this project because the business just wants to see the potential first. So after that comes the most popular, not probably popular, the favorite part of the project for all the developers, growth phase. So what is a growth phase? We have released some functionality, MVP is ready, the client is happy, and the business sees the potential in this project. So the business starts investments. The business starts hiring more developers, engineers, DevOps, designers, QAs, and so on. And we are starting working on new features. Yeah, we have a huge backlog. We are doing heavy coding, and that's the most interesting because we can experiment, we can introduce some interesting solutions, we can create some cool architecture and so on. And at this phase, we are usually starting to think about the future. For example, is this tool a proper variant for us? What the test coverage should we have? What is wrong with our processes and so on. After that comes the most boring part, the stabilization phase. So let's imagine our product turned 18 months on, or a year and a half. So what happens? Usually we code less. Yeah, we have a huge source base with many users, with many clients, and we need to support all this code base. Usually we spend more times on bugs than on coding at this phase. all the essential functionality the client needed is already delivered. So as I said, it's a bit boring, and at this phase, situation, our coding is getting slower, and slower. We're usually getting stuck in all these problems, but yeah, we'll discuss it a bit later. And what's really important for business here is since the main functionality is delivered and the business has its clients, employee managers, and so on, business starts working, and business doesn't understand usually anymore why it needs more investments, because, well, the project starts making money. And after that, let's say the project turned 4 years, and here comes the worst phase we all hate. It's called support phase. So at this phase, we are usually not writing code. We usually reading the code, right? We have a huge source base. We have a huge number of different bad decisions we made up initially, but they're too expensive to refactor them, to change it. We are getting our tech stack outdated. Like, imagine, for years, it's class components existed for years. I mean, hooks were in React were introduced 4 years ago. And what's worse for the business at this phase is usually at this phase, things are getting too much time, and business is suffering to implement some new features. And usually after this phase, we all realize that, okay, guys, we have outdated stack, we have bad solutions for some parts, and we need to rewrite the entire application. And usually it's very expensive, very risky, and usually the client is really unhappy about that. So let's take a look at the close, as I said, very, very close to real life example project. It's called Best Shipping and Delivery. It's a test name, nothing common with real projects here. Let's try to analyze these phases according to the real life example. So how it works and how this timeline applies to the problems we have. So a few words about this test project. Yeah. So the company it's a huge company which is responsible for shipping of different cargoes across European countries, let's say from Berlin to Paris, Rome to Barcelona, and so on. It has many offices in different countries. It has more than 10,000 employees. So you can think of it like a competitor for DHL, Mist Express, Nova Posta, somewhere else. So let's take a look at the phases, how it might look like. So we are on the first phase, MVP. So the client wants us to implement some basic automation things. So instead of storing all the data about the vehicles, manufacturers, dispatchers, and cargoes, they want to make it all store in the centralized database and so on. So what we have here, we're doing a bunch of different forms, tables, so the most boring things on the front end, right? And we have like, let's say 4 months or 5 months for this. We have a relatively small team, like 2 or 3 front-end developers, 2 or 3 back-end developers, like QA, team lead, project manager, yeah. So what challenges do we have at this phase? Usually the main challenge here is to meet the deadline, yeah. And when I say meet the deadline, it means both coding, some organizational tasks, like form the team with all required positions, and usually we try to write not the worst code, yeah, at this phase, but that's not our focus currently. And we really need to show the client us as a team, yeah, so we are experienced, we know how to do things, and the client needs to show this application to the real users of this application after that. Okay, we are getting closer. We are currently on the growth phase. So 4 months in 4 months we delivered some functionality. The client is happy. The client showed this to the board of directors, to managers. They're all happy, and the client starts massive investment in our project. Yeah, so there is a bunch of features we need to develop. The backlog is huge. So first of all, we need to develop live tracking module. So imagine like many vehicles, they're driving across different European countries. We have different sensors in them, like GPS position, fuel consumption, and so on. So quite complicated functionality. and we want to optimize, analyze it, and so on. So we want to have alerting system, cargo control, more crowd operations, like want to have an employee management system, and so on. And the team is getting larger. We are, let's say, have 30 to 40 engineers on different parts of the application. And what challenges do we face here? As usual, the first problem is separation of concerns. Yeah. So who is responsible for which feature? So team one needs some component and team two needs some component, or let's say they need to change something simultaneously. So who is responsible for what? How exactly it should be done? We are getting first blockers, like team one needs team two to implement something, but before team two needs another team to help them with something, and we are getting stuck in these processes. We are thinking about the architecture and technologies to choose. Yeah, on the growth phase, it's really important. Also, we are trying to test our functionality and so on. So at this phase, things are not yet as bad as they will be in the next phase. So we're getting to stabilization phase. In terms of functionality, we're adding a bunch of new analytics, dashboard, vehicles management. We're adding integrated payments, advanced authentication, contract system, and so on. So it's about, let's say, 300 to 400 pages per application. What problems we have at this phase? Of course, all the problems we had before, but they're getting worse. So the separation of concerns is now is even worse because there are more teams. Yeah, as I forgot to mention that team size is growing as well, because many people who initially started the project have already left the company. They're not working on this project anymore. We don't know what does this module do, or why it was created. So can we refactor this safely, or it has dependency on another team or another module? It's quite hard to scale the application. It's quite hard to do proper versioning of because as for internal packages, the same for external. Because, for example, we need to update the library to use some brand new features of the new version, but whenever we update it, we might accidentally break something of some functionality of another team, and we can that way deliver a bug in our production. So, and we start to think about we start facing the situation when the technology stack is getting outdated. And the last phase, which is really the worst is the support phase. So in terms of functionality, we're adding real time for everything. We're adding reporting system, notification system, and well, you might imagine yourself how many functionality we might have in such a huge project. Yeah, and basically the situation is the same here as the problems are the same as for the previous phase, but now they're really painful. So we are just get stuck. So the very minor feature requires a sprint of work. However, theoretically it needs a day of work or a few hours. And we have a huge team. We have many issues in terms of versions, in terms of outdated libraries, in terms of just generally code sources, and so on. So let's try to, according to these phases, analyze what are exact disadvantages of the monolithic front ends. Oh, sorry, front ends, not micro front ends. Yeah. So according to phases, yeah. For the first phase, MVP phase, let's make it clear there's nothing wrong with the monolith at all. So we want to make to deliver functionality as soon as possible, as fast as possible. We want to we don't want to spend so much time on configuring something and so on. We just need to deliver. The next phase, it has some problems already. So yeah, as I said, the first is poor separations of concerns and scalability. So as I said about that, we can just move forward. The second is Git flow. Well, as usual, we have conflicts because we're different teams touching the same modules, same files, and so on. Sometimes we have issues, for example, with releases. Yeah, you can imagine the situation when you have just finished a feature, but the developer has some but the build, let's say, is red because of tests, because of ESLint issues, or it contains some bugs and we cannot deploy anything, but just because the current develop is broken. So we are just blocked with this. Yeah, as I said, tight coupling between the modules. Imagine we need to, team 1 and team 2 need the same shape of data from the backend, but they need to map it in different ways. Yeah. Or they need to use the same store, the same context, but with some differences. So is it safe to refactor it or not? So usually it becomes a real problem at this phase already. Yeah, cross-team dependencies. So when one team requires team 2 to do something for them. Versioning for different packages, modules, and libraries. And of course, independent testing, because testing is getting really complicated because imagine you have a bunch of different stores, providers, modules, frameworks, and so on. And it's quite hard to unit test it, yeah, because you need to mock everything and the tests are breaking just because another team changes the implementation and you need to remock it somehow. And the same for end-to-end testing, yeah, for our QA engineers, because well, you can imagine the situation, the QA trying to test something and it's broken, but it might be broken not on our side, yeah, it might be another team that broken something or something like that. For the stabilization phase, we have pretty much the same situation, but there are more problems. The first is too high entry threshold for newcomers, and that's pretty common situation. Yeah, you can imagine a huge application, and when there are too many developers, and they're constantly changing, someone is leaving the company, someone is being hired, and so on. They're coming and they don't understand how it works and how it should work. And we need to spend months to onboard these developers. Second core issue is impossibility to introduce independent changes. Yeah, imagine we need to update a button for our purposes or table for our purposes. And of that, when we try to update it, we see that it has like 100 occurrences in our code base, in different modules, in different packages, and we need to go through all of them to refactor it and we don't even understand what they're doing, so it's quite hard to test it. Yeah, and of course we have a bunch of different shared things which are quite hard to change and refactor. And the last support phase, pretty much the same, but the code here becomes really huge. It's a real mess, and it's literally impossible to extend the functionality without breaking something. So you fix, you need to add some validation on your fields, and somehow you break another page. How it happened? Just because another team decided to change something, and you rechange their functionality, and well, you know how this mess works. So basically, the application is very hard to support and update, and very minor changes require a huge amount of time for testing, for delivering, and so on. So what we can do to get the situation better? So of course, we have Microfrontends. So yeah, meet our hero, Mr. Microfrontend. That image was generated by ChatGPT. ChatGPT imagines Microfrontend like that, like a superhero. So what is basically Microfrontend? So if you have experience with microservices on the backend, you can think of Microfrontends as pretty much the same thing. If you don't have experience with microservices, you can think of it as breaking a huge project, yeah, into smaller pieces, modules. Just for simplicity, you can imagine a lazy loaded route in your Angular, React, or Vue.js application, yeah. And imagine this lazy loaded route would be not just a component, it would be another external application delivered by another team, and you don't even need to bother how it was developed, so what technologies were selected, and so on. Sounds good, right? So in a few words, how it can help us. And after that, we'll go through all this point in more details. So first of all, it allows us working independently. That's the most probably important feature of the microfrontends. So we are working on our very own feature, right? We don't need to stress about other team doing some shit in their projects, in their microfrontends. So we are code owners of only ours application. So, and we don't need to care about anything, right? So it leads to the fact that we can fix the things without the fear. So since it's our very own application, we just fix the bugs. We didn't have any external dependencies, right? So we fix the bugs, we release the feature, we release the bugs, the feature, and that works. So amazing. Yeah, the same with the updates. So we can add new routes, component stores, whatever we want, and we don't overlap other teams at all. We have independent testing functionality. It's very important for big projects. Yeah, we don't have any, and as I said, it works for both unit testing and end-to-end testing. We don't need to mock anything we're not using, and we know if our tests are failing, they're failing because of us, not because some teams change something and so on. The second thing, which is probably the mostly important for the business, not for the developers, is independent deployment. So imagine we have today we need to release some feature, and if we don't have the situation with the monolith front end, we have it's quite common situation when the develop branch is broken, and we don't know who broke it and so on, and we need to wait for all the teams to fix their functionality during this. For example, we finished this feature a week ago, but team, let's say 7, they haven't finished their functionality, and we are blocked, and we cannot deliver new functionality. Of course, there are some hacks how to do it. We can cherry pick, we can do partial releases and so on, but that's just a hack, and it's not very convenient way of working on the front end. Yeah, and of course, we might have different stacks. So I'm not encouraging you guys to use Frankenstein written in all the frameworks you might imagine, yeah, but theoretically it's possible. Sometimes it happens that, for example, the customer has an external team, and this team knows only some framework, and you don't like this framework or you don't know it. You don't need to care about that. You can just work in your favorite framework, and they can work in their favorite framework. What is really important for me is a real code ownership. This means responsibility. So because when you have a huge team like 200 people working on the same project, you don't feel personal responsibility on the project. Yeah, you just feel like, well, this button was written by abstract John, yeah, and he is not good at coding, and I don't care about this. When you have micro frontend, you have your own repository. Well, not probably repository, but your own project. And you're really personally responsible for that. All these facts lead to the flexibility. So you're flexible to select your tech stack, when to deploy, how to test, whatever you want to do on your application part, you're free to do it. And just in a few words, perhaps some of you guys have worked with the old style iframe micro frontend. So comparing to them, the main benefit of micro frontends is ease of use and communication. So we can easily connect micro frontends to communicate between themselves, but we'll discuss it a bit later. So let's take a look at our lab red, yeah, best shipping and delivery in terms of the growth phase, how it might look like if we used micro frontends for it. So we have an application container. So it will be just this global host, as it's called in micro frontends. Yeah, we have navigation application. Oh, it might be not. So it's quite. So it's up to you guys how you would like to organize it. We have live tracking module. So that's a separate application, and the live tracking application team shouldn't care about other modules. And here we have different applications. So that might be one application for all the user management, live and vehicle management, or it can be different applications. So as I said, it's quite flexible, and it's up to you how exactly to select it. And at the support phase, the situation is pretty much the same, but we have just more application like analytics application, contracts application, vehicles management, notifications here, and so on. And let's finally start to talk about the micro frontends. Yeah, how about from the technical point of view. But before we start discussing the how to code it, let's just discuss 3 main architectural rules we need to follow when we use micro frontend. So this is extremely important because if you break these rules, micro frontends will probably will be bad for you. So you'll create more overhead than real benefit for you. But if you follow these 3 simple rules, everything will be just amazing. So the first rule is independence. So keep in mind that every time you want to do something, you need to make each micro frontend as independent as possible. So you should not create any direct dependencies from one micro frontend to another, or to something like we'll discuss a bit later what exactly how we can fix coupling for the micro frontends. So basically, the independence, as you know, is the ability to develop, test, and deploy parts of our application in isolation. So this is extremely important rule. Second is autonomy. So each team should be able to make decisions regarding their slice of application. So they should be able to select their own stack, deployment strategies, testing strategies, and the application should not bother about their neighbors, like another micro frontends or host application or anything else. And the third rule is integration. So as I said, we don't want to create a Frankenstein, so one micro frontend using Material UI, second is Bootstrap, third is something else. So all the micro frontends should be seamlessly combining this into one unit, without the compromising on performance or user satisfaction. So, and let's finally discuss the ways how we can implement micro frontends in terms of technical details. So first thing we can use, and which is, in my personal opinion, the best way for 95% of the cases, is just plain old module federation. So this is even not a separate tool like a framework or something else. That's just a built-in functionality plugin for Webpack 5. Just for your info, Vita and Rollup, they also provide the module federation plugins, but for now, Webpack has the best capabilities for the micro frontends. It has the best ecosystem and library for different performance optimization techniques, but that's another topic. So we are not going to talk in details about the performance optimizations. That it basically allows building multiple independent builds from a single application. So let's take a look at how, in theory, it works. So we have 3 parts in module federation. So this is host application, remote application, and federated module. So think of, you can see it here, how it works. So host application, this is the main application. This is an entry point. It loads and displays all the federated modules. It's responsible for defining where to load module, where to render them, and so on. Remote application is an application that being loaded by host. It exposes some parts of their code, and these parts can be consumed by other remotes or host application. And these parts are called federated modules. What is really interesting and important here is each remote application can expose different modules. So it's not an only, let's say, entry point. It can theoretically, it can expose shared UI library, a bunch of different buttons, inputs, tables, forms, and so on. Also, it can expose a few types of application, let's say, for different plugin system, let's say, and so on. So it provides a bunch of capabilities, and we'll take a look at this in the next part. Here you can see how you can configure your module federation config. So imagine you have your host here, and it has, we're still talking about the best shipping and delivery company. So it has 3 remotes. Just for simplicity, we're not going to cover like 15 or 17. We have dashboard application, analytics application, and live tracking application. So here we just pass where to get them. For this case, we're just using localhost, but for sure we can use some external IP or domain. And this is an example for analytics application. So you see it's here, So here analytics and here. And here we can define what exactly we're exposing from analytics application. So for this case, we're exposing sales analytics and fuel consumption analytics. There can be as many different bundles as you want. As an usage example, it's really simple. As I said, it's just the same as you would import lazy, just use lazy loaded route. So you're just using it like this. So this is a sales analytics. So you see here you are defining and here you're using it like this. So you're just importing it from this path, and the Webpack will know that you're the same. It's the same for Vita and Rollup. It will know that you need to download it from, let's say, some external IP or domain. So this is a React example, the first part, and here is the same application, same example for Angular. So pretty much the same. We're just loading the remote module like this. And are there any disadvantages of module federation approach? Only one, actually. That's a multi-framework applications. So theoretically, you can lazy load like Angular and React application simultaneously, but it doesn't work as you want to work, let's say. So it's quite hard to create a proper routing, let's say, yeah, for mixed application for React and Angular or Vue.js or something else. For this specific case, there is a library called single SPA. Well, yeah, it's not even the library. It's a full-scale framework for building micro frontends, and it's quite sophisticated. It has a huge ecosystem, huge number of different plugins and libraries for different application. It has some pre-built libraries for React, Angular, Vue.js, even Svelte, as I remember, and so on. And it has quite high entry threshold, and so just keep in mind that like 95% you don't need it. So prefer single SPA only when you need it. So what is a single SPA and its core concepts? So in single SPA, we don't have federated modules. We are always exporting only one application from micro frontend, yeah. And we have a root config in single SPA. So this is an entry point of our application. Yep. So it's responsible for registering all the micro frontends and setting up the routing. We have micro frontends, and they can be written in basically any framework, or they can be even using vanilla.js, so whatever you want. And what is really interesting here is we have lifecycle functions, for example, for mount and mount, for bootstrapping the application, and so on. And the single SPA provides libraries for React, Angular, and other frameworks to use them and to just to reuse them. Okay. So this is an example of a single SPA config. Yeah. So we are, as you see, we are using system import organization F1. This is really the worst part about the single SPA. Well, that's quite self-explanatory, but anyway, single SPA doesn't bundle your micro frontends by default. So it's your responsibility to bundle it yourself and to provide it to single SPA in the proper style. Yeah. So, but on the other hand, it works fine with System.js, ES modules, UMD. So if you know how to bundle your application, it shouldn't be a big problem. Yeah? And here you can see an example for a single SPA layout engine routing example. Yeah. So in the previous example, we were just registering all the application, and here we are rendering everything. So it uses HTML-like style, so we use it in CGS file. Yeah, so here we have a application and name here. So this name could be, for our case, let's say dashboard, host, live analytics, tracking, so whatever. So that's pretty much it. Yeah, a few words about the rest of the micro frontends ecosystem. So there are other libraries and frameworks for building micro frontends, but honestly, these two are currently the best in the market, and you shouldn't even try to look at others because they have very weak support. They are not really stable and so on. So probably you don't want to use a library which has like 500 downloads and NPM, right? So for now, we can stick to only two of these. What the problem do we have? Yeah, let's talk about the challenging situations with the micro frontends. What the problems we might have, and how to handle them. So first, as I said, you can consider this part as just an advices how to make your micro frontend architecture work and how to not dive into the pitfall of different bugs and so on. So first of all, we need to care about the independent deployment. This is the most important part in the micro frontends. So when you make the deployment dependent, so you cannot deploy something without something. This is not, this violates the logic of micro frontends themselves, yeah? So by default, module federation and single SPA, this enable this, and there should be no problem. So you just deploy your application to some URL, and after that, import it like this in single SPA, or you're just exposing this module for module federation and loading from your company IP or domain. That should work fine. Yeah. Let's just repeat it, that you need to keep your micro frontend architecture as autonomous as possible. So each team should be autonomous and shouldn't have any external dependencies on other teams. So this is encouraged by default by both single SPA and module federation, and we can move forward. So yeah, isolation. So it comes very close with the previous rules. I mean, the independent deployment team autonomy, but from technical details, we need always to be sure that our micro frontends do not overlap in some things. For example, we should use unique namespaces for CSS, or we can use web components, for example, or Shadow DOM to avoid the situations. We should care about using the global window, for example, if some of the micro frontends might use it, and so on. So just generally, we need to avoid all the clashes between the micro frontends, and that's also really important for us. Yeah, for sure, we need to have consistent design to make our application not look like Frankenstein. So we need to have usually to implement a design system and share it with NPM or module federation. As you remember, I said that version is usually a problem for our monolithic application, and what's worse and what's wrong, and how micro frontends can help us with this. As you see here, as just for example, as this is an example for module federation plugin, yeah, and it uses singleton true. So it means that this library, this package will be shared as a singleton between all the micro frontends, but we can change this implementation. We can share different libraries. And for example, if the UI library team has developed brand new buttons or tables of forms, they can just create a new version of it, and our application will be still using, let's say, previous version, and we can update it whenever we want it to do. Yeah, quite simple. Yeah, so shared libraries, yeah, same situation here. That's more about the performance. Yeah, we need to try to share everything. I mean, for each micro frontend, if you have 10 React micro frontends, they should not contain and bundle like React Router, React Redux, and so on. So try to share the libraries to reduce the bundle size. And the most important, the most interesting part, we haven't discussed yet, the communication. So it's quite simple to communicate between the micro frontends, but you should never make the communication direct. So because the general idea is to lower coupling, not to create a direct dependence from one micro frontend to another. So how you can do it? There are many ways how you can do it. In the backend world, we have more sophisticated approaches like Kafka, RabbitMQ, and so on. For the front-end world, we can use quite simple approaches. Like, first of all, is simple publisher subscriber approach. We can do something like this, like create event emitter. It can be custom event emitter, yeah. We can pass it to window, and we can, from one application like live tracking, we can emit event, and we can subscribe on this event in, let's say, notifications application. Also, we can use web workers. For some cases, it's more complicated approach, and you might use it for the cases when you have some performance optimization techniques, yeah, when you're doing something heavy, CPU heavy, I mean, in your web worker, and so on. Yeah, and usually in terms of sharing store, it's considered a bad practice, and you should try to, and you should always avoid sharing business logic in your store. But you can sometimes use like high-level store for different micro front ends for some logging, error tracing purposes. But you should better avoid doing some complicated mapping and storing some business logic there. So the next part is testing. Yeah, so each part should be well tested, and the best approach here is common test environment. So we write unit tests for our individual components for the micro front end, integration tests for interactions, and end-to-end to test to cover all the micro front ends communication between themselves. Yeah, performance. That's another huge topic which we'll be not covering in this workshop because it's quite complex part. But just in a few words, single SP provides a bunch of different capabilities to optimize your performance. And you can use, for example, prefetch, or for Webpack, you can import for lazy loading your parts of application, and for sure try to reuse shared libraries if they are shared libraries, and try to move CPU intensive things on the backend, well, or at least in the web workers. And since it's still possible to use different frameworks, well, anyway, try to stick to the same tech stack in your application, because well, it's quite hard to support and to find engineers if you have like 5 frameworks on board, and you will need for this engineer to change the teams and so on. So I believe you understand how it works. Yeah, for sure, for sure the documentation. This is the problematic part for all the application. So make sure all the team members know how to work with your micro front end. So centralized wiki or at least readmes will be just an amazing thing here. And probably the most complicated part for the micro front end worlds is the server-side rendering. So server-side rendering is generally a problematic situation for the front end for Angular and React. And from my personal opinion, if you rely on SEO hardly, well, think twice if you need micro front ends, because if you have too many micro front ends, it's quite complex task to implement proper server-side rendering. So, as an example, what you can do to implement server-side rendering for the micro front ends. So you need a shell application and a Node.js application, which will be like combining different outputs from Next.js. So it might look like something like this. So imagine you have micro front end for product listing and another for product reviews, yeah. And with this SSR, whenever user navigates, let's say, to this URL, we are getting the output from rendered product, from reviews for product, but we need to do it all manually. We need to manually combine this output from Next.js, and it's quite hard to properly hydrate them after that. So I'm not saying it's impossible, yeah, but that's a quite complicated task, yeah. And if you do rely on this hardly, then it might be a problem for you. So yeah, I believe we can finally switch to some practical examples. And I've just, as I said, I prepared 3 applications for you guys. So one is using React Module Federation, one is using Angular Module Federation, and one is for single SPE. So let's take a look first at React application. So how it looks like. Yeah, I'm using NX here, and that's topic worth another workshop. On repositories against the multi-repositories. But I truly believe that if you work with micro frontends, you should prefer mono repositories, because it's easier to reuse your code. It's easier to do everything actually in mono repositories if you work with micro frontend. So I use NX here, and yeah, I'll provide the working example for this repository. So for this, I've created we have an repo with all these 3 projects at our corporative GitHub. So it will be provided, so we can fork it or clone and play with it yourself. So yeah, how it works. As you remember, we had different applications. For the simplicity, I've just created 4 of them. So we have dashboard, host, live tracking, and notifications. So let's take a look at the host, how it works. Quite simple. Here in module federation plugin, we select which remote we have here, yeah? And give me a sec. And in webpack config, we specify where to load the remote. So in your production case, it will be just not localhost. You can specify it with n variables, yeah, where to load exactly this URL and so on. And quite simple. And here in application, we are just lazy loading these applications like this. Yeah. So dashboard module. And rendering like this. As I said, just lazy loaded routes, no rocket science here, so quite simple. And in terms of the remote applications, they look like this. Just give me a sec. So yeah, we just specify which module we are exposing here. So we're exposing module, and it is remote entry like this. So very, very simple. Yeah, each application has also a README file with some instruction how to configure it properly. So let's try to first of all, let's try to run only one microfrontend, yeah, remote application, and let's understand how ideal is it that we can work on only one project without bothering about others. Yeah? So let's just try to start live tracking application. So for the simplicity, for sure, we're not going to implement fully. Just give me a sec. Which URL is it? No. Yeah, sorry. Like this. So imagine this is just a map. So in real life example, it will be a bunch more functionality here, but for now, well, that's just one application. And we can, if we try to run it like this, we just specify dev remotes here. The same functionality is available for TurboRep, Lerna, and other monorepositories, and you can do it yourself if you work with multi-repo approach, yeah, but you'll just waste too much time on this. Okay, let's run all of them together. Oh, sorry, yeah, like this. So you see, yeah, this is live tracking module. It's sitting under the URL live tracking here. You can implement nested routing here for if you want, so it can be like this. That's not a problem. And here's the dashboard. Here's live tracking, yeah. And also, as you remember, we have a notifications application. So it's currently some functionality commented. Just give me a sec. So we're hiding notifications here. Let's try it like this. So you see, now we receive notifications from live tracking. If we go to dashboard, we receive notifications from the dashboard. So yeah, new report available and so on. How it can be implemented? Quite simple, actually. We have a library. If you don't use NX or something like this, you can just add this functionality to Windows. So you can do something like this. Yeah, window event bus and so on. Yeah, and we are just passing a singleton instance of this event bus. And whenever we subscribe to it, and we subscribe to it, yeah, in notifications application, like this. And whenever we receive some notifications, we just handle them. We're just showing snack bar. And our, let's say, dashboard application has the functionality to show this in, let's say, 1 second or 2 seconds, yeah, like this. So we're just dispatching event. New report happened, yeah, new report received, and we're handling it in the notifications applications. Really simple and really, really useful. So that was an example for React. Let's take a look at the Angular application. So for Angular application, I decided not to copy paste this functionality. It will be a bit more simpler. Let me just start it. So yeah, no maps and dashboards, but probably we don't need it here, just for understanding. Yeah, as you see, we're changing different URLs. It works fine, and so on. So how the code for configuration looks like? So pretty much the same. Just give me a sec. Where is it? So let's say, yeah, we have as a host application, we have dashboard here, and so give me a sec. So yeah, here we are providing our let's start from analytics. Yeah, we are just providing this entry point. So we have a remote entry component. So it's here, and we are just providing it in entry routes. After that, in the dashboard, we are just rendering it. Yeah, and only one difference from the React approach is for Angular, we need to have module federation manifest. So here we specify the URLs where to get this other microfrontends, but pretty much it works the same. So after we load this manifest, we just bootstrap the application, and we have app routes, yeah, and analytics is loaded just as a simple lazy loaded module. So no rocket science here at all. Yeah, these were examples for the module federation. Let's take a look how it would look like for single SPE. For single SPE, yeah, I've forked an application for Rick and Morty. So I've mentioned it in the README. It wasn't my implementation. But what is really interesting here, we may look at implementation. Just give me a sec. Where is it? So yeah, we are using a bunch of different internal applications and plugins and libraries for single SPE. For example, single SPE provides library for React, also for Angular, for Vue.js, for Svelte, as I remember. About Svelte, I'm not sure. And here we can specify all the lifecycle hooks, how to render it, how we should build it, and so on. So yeah, you see we're providing like a bootstrap mount and unmount lifecycle hooks for a single SPE. And in terms of rendering, well, let's first take a look at how it looks like. README, yeah, and start all. Oh, sorry, forgot. So, and we should go here. So yeah, you see this is a Rick and Morty application. So we have this routing to applications, episodes, and by episodes and by location characters. Yeah, and here we have shared top navigation just to show how it works. And let's take a look at the host application and what it provides to us. So in the application, we specify, first of all, we specify how we should load the application. I'm not going to explain all the details how it works, because as I said, it's quite a sophisticated thing. And if you want to use a single SPA, then you probably will need some time to understand it, how it works in details, yeah? But in terms of usage and rendering, yeah, here we specify libraries we use. So here goes the Firefly episodes and where to load them. So you see it's localhost 9001 and 9002 for locations, yeah. And the routing is just give me a sec. So yeah, and here is the routing. Sorry, I just overlooked it. So we have a navigation here. We have applications here specified like this. Yeah, you remember it was a Firefly application. I decided not to touch it because it was forked. And the path where we can load it. So yeah, and here we can just for info, you can have a nested routing, for example, for your React or Angular application, which will be sitting under this route and so on. So basically, this is an example how you can implement your micro frontends easily. Yeah, I believe it shouldn't be really big trouble for you. So let's get back and let's talk about the example we had in our company. Yeah, so an example of Intellia's application refactoring. So what we did, we had an application for internal interview portal. So this application was responsible for management for employees, candidates, marketing data. We had a bunch of functionality there, like calendars, like filtering, advanced searching, and so on. So yeah, this is how it looks like. So don't be scared. That's a development environment, so it's pretty empty. And it had many just how it looks like. So this is a forms for actual interviewing process. We had a real-time connections for different rooms. For example, if there should be many interviewers for the one candidate. Yeah, and let's discuss what the functionality we had and which challenges we had with this functionality. So first of all, that's the interviewing process. So we need to be able to list all the possible skills, job profiles, forms, including group reviews, different visualizations for skills, like this, for example, yeah, and so on. There are more of them. So applicants management. So different crowd operations with advanced searching, filtering, sorting for different candidates and different access rights. What is really also important is access rights. So because as you understand, there are access rights like interviewer, recruiter, delivery manager, top manager, and so on. And according to this access rights, the functionality differs seriously. Yeah? On the backend, we had Nest.js and Cosmos DB, serverless functions. That's probably not our main focus today. Yeah? And for the authorization, we used Microsoft Authentication Library, MSAL. Also, we had a bunch of integrations like with Jira, with Microsoft Teams, Mail as internal system, for example, for learning and personal development, and so on. Also, we had admin side. So there we were storing feedbacks, reviews, functionality, different visualizations for processes in the company for months and years, let's say, yeah. Crowd operations for interviewers, applicants, recruiters, advanced marketing data, and so on. And it had its own access rights configurations. And also we had additional functionality like calendars, like onboarding and tests for interviewers, which were going to start this process at Intellis. Also client-facing interview reports. So for example, the interview has finished and we're sending to the client the result in the form, which will be understandable for client, and the client won't be able to see anything else except the long and encrypted link. Also documentations, wikis, and so on. So which problems we had? Initially, these were, it existed as many separated applications. So they were basically independent. It was quite hard to use the shared functionality, do some general level actions, like, for example, showing notifications, asking for feedbacks. We had to load the same data twice, and so on. So you may ask why we decided not to move it one monolith, yeah? First of all, we needed independent deployments. So imagine we fixed a bug for interview portal, but the admin portal is still in progress, so the feature is not ready yet, or vice versa. So how to publish the fix? So with the Microfrontends, that's not a problem at all. So the time between the fix and bug and the bug is being deployed and released is very low with Microfrontends. Yeah. Second reason is access rights. So as I said, we had a bunch of different limitations and minor things according to the access rights. So each part of the application had a bunch of different access right details, and it's really hard to handle them. So, for example, some parts of the app had public visibility, yeah, and it was much easier to handle that from the standard type list. And when we were, for example, working on the forms for the interviews, we would focus only on this, and the logic for handling all this authorization will be handled in the outside. So the code split, yeah. So the libraries were really different for different micro frontends. Some of them were using Mobix, some of them were using WebSockets, D3, etc. So we don't want to make them. And of course, the testing is, so if I want to test the dashboard filters, I don't need to mock the socket IO, for example, yeah. And as a result, currently the application looks like this. So here is the application dependency graph, here is the backend, here is the front end. Well, we're not going to talk much about the backend, but for the front end, as you see, the dependency is quite simple. We have a library for React, only for React. Here we have interfaces. So interfaces is actually a shared library between the backend and front end. Here, there we store some interfaces, some shared data, but it's not really some types and so on. And as you see, what is really important here, we don't have any direct dependencies from client admin, for example, to client home. Yeah, they are all absolutely independent. So you can work on, for example, on client home, and you need only library for interfaces and for React, and that's it. Yeah, and general graph looks like this. So yeah, we were really absolutely happy with this approach. It allowed us to significantly improve the development speed and the speed of delivering the features, fixing the bugs, and so on. And well, it's just, as for developer perspective, it's just very convenient to work in this way. So this is the application implementation. So as I said, we used MSAL library, yeah, and we had a problem we discussed, yeah, isolation and autonomous deployment, autonomous work, and so on. But how we can work with authorization to make it work? For example, I want to run only one application, yeah, only one micro front end, and it has to deal with its own authentication, right? But what to do in case if if it's rendered by host? Quite simple. We're just as I said, it's with module federation, that's just a component. So we are just passing these props, like running as micro frontend, Boolean flag. And by default, when we are running this application, as I showed, for example, for live tracking module, it will be false and it will be handling its authentication itself. If for the host, so yeah, this is the host application. For the host application, we're just passing these props here, like running as micro frontend true, and it won't be handling its own authorization. It will be handled by the host. So really simple. That's, by the way, one of the topic which is considered to be a complex thing in micro frontends, how to handle authorization. Well, like this, for example. Yeah. So I believe we have gone through most of the technical details. For sure, there are more things we can discuss in terms of micro frontends, yeah, but like server-side rendering, performance, and so on. But that's probably a topic for another workshop. And let's just try to summarize and to talk when is it worth using micro frontends. So when it will be when it is going to benefit us. Definitely worth it. When you have multi-framework front-end applications, that's the best solution. So I can't imagine how you can live without that. And if you have a really large-scale application, so I would say hypothetically like 20, 30 engineers per one front-end application. I mean, not the general scope of engineers. Yeah, I mean, only for one application. If you see that you have more than 20 or 30 engineers working on one application, then probably you should split it. Also, it's worth considering the using micro frontends if you have many modules that have low to no connection. So, I mean, they can be easily isolated. And if you want to have faster deployment cycle for some of application parts, sometimes it's really important for business. Moreover, if you work in some marketing sphere, for example, when you need fast deployment cycle, yeah, and so on. Also, if you need some multiple versions of the same application widget system, for example, for managers show this application, this plugin, for public access, this plugin, and so on. And if the functionality is really looks the same, but not exactly, then that's also definitely worth trying micro frontends. And also, it's not too popular, actually. But if you want to do A/B testing or other experiments, micro frontends also work just ideally. When you should not try micro frontends, when it's an overkill. Well, of course, it's small to medium-sized projects. Well, if you if there are two front-end engineers on the project, then probably you won't benefit anything from the micro front-ends. And short-term project. So if there are no modules, routes, functionalities that can be isolated, so in other words, the application behaves as very tightly coupled systems, then probably you don't need micro frontends at all. But from my personal experience, that almost never happens. Almost always you can somehow split the application. So that's quite a rare case, and I cannot even imagine in which domains, probably in some calculations, if you application do some, imagine your application doing one process, only one process. So perhaps it's also an overkill. But as I said, that's quite a rare situation. Also, when you have critical resources limitations and you don't have, and you're not going to support it in future and so on, then probably you also don't need it. And as a conclusion, so what it brings to your business, I just want to make it, so we've gone through all the technical details, and let's try to sum up what it brings exactly to your business. So first of all, it's ease of extension and scaling. So if you need to add new functionality, just an epic, a new huge functionality, you just need to configure one more micro front end and start it from scratch. You don't need to deep dive into the legacy. You don't need to onboard the engineers how and why 5 years ago someone has written something. You can just start a new application and reuse something if you need so from another modules which are exposing some functionality. Second thing we haven't gone through yet is fault isolation. This is probably the topic very popular on the in the backend world, but on the front end it also matters. So imagine the team has deployed broken feature to production. If you have a monolith application written in Angular or React, well, the page is just going to go blank, so you'll have an error, or if you have some error boundaries or error handling, you will just see like, oh no, something is wrong. But if you are using micro frontends, well, only one small part will be unresponsive, and that's much better for business and for business clients. We mentioned this. We have much faster deployment cycles. So if one team is stuck doing something, they don't know when they'll be ready to fix something or to deploy something, that's totally fine. The rest of the teams can deploy their features independently, and we don't need to care about the team stuck on some of their internal stuff. Also, we have incremental updates. So imagine it is year 2028 now, and all the frameworks are currently outdated. And for example, everyone is using some, I don't know, Svelte, Vue.js, whatever. So if with monoliths, it will be a huge risk and huge problem for a client. It will be needed to rewrite the entire application from Angular to or React to and something else. It will be very risky. It will be very expensive, and it will probably contain a bunch of bugs, because you know how it works. When the application exists like six or 7 years, all the bugs are already found mostly. When you create a new application, you will have some bugs anyway. And with micro frontends, you can go incrementally, like update only one small part, rewrite it to Angular or React or something else, and you can see which problems you have, which mistakes you make, how exactly you work, and so on. And you can do it step by step without any problems. And also you can have multiple versions of the same application for different purposes. So generally, this is the developer satisfaction rule. So with micro frontend, we have flexibility and productivity. So we don't need to spend months to onboard newcomers, explain the legacy code. We just can focus on our own features. We can use the libraries and technologies we prefer. We don't need to care about what the other teams are using. And for sure, testing. So we can test our code independently. We don't need to mock the things we're not using. And the same for QAs. There are no external blockers for them. They can just test the exact features they need to test, not to test the entire application if let's say, authorization is just generally failed in another application. So I believe we've gone through most of the topics for micro frontends. So yeah, thank you for your attention. And now we can go to the Q&A session. So I'm waiting for a question, guys. So, and yeah, here goes the link to the GitHub repository. So you can pull from, you can clone it to your local machine and try to play it yourself. So yeah, thank you for your attention, guys.
Thank you. Thank you, Mikita, for your presentation. It was really powerful and full of different examples. I see we have quite a bit of questions here, and as people were asking questions during the presentation, some might have been already answered during the next steps in presentation. But I'll still read them, and you will maybe mention again something. So the first question, what about disadvantages of micro front-end?
Yeah, I believe we've gone through them. Basically, thank you for this question. So basically, the main disadvantage of the micro frontends is configuration hell. So sometimes when you have a bunch of different micro frontends, you have different environments and so on, and you need to have proper CI/CD configured, and usually you need to bother your DevOps to configure it properly, yeah? And initially, when you start the project, it might be an overkill, as I said, for the MVP phase, because it really takes much time. Also, sometimes you need to copy paste your code with the micro frontends. Yeah, that's true. But honestly, you sometimes copy pasting is better than creating some shared logic which will never work, and you'll just need to have a bug there, and you'll need to refactor it each sprint and each week of work. So these are the basically main disadvantages of the micro frontends. Yeah, and of course, and of course, server-side rendering. It's quite complicated part.
Thank you for your answer. Let's move to the next question. It is, if you use UI kit, how do micro frontends works with modification within the UI kit? Can changes in UI kit break anything?
Yeah, I believe I also covered this topic. So, for example, if you have your own UI library, if I understand your question correctly, then you have a few options. So, for the start of the application, when you can just directly change the imports, update something, and so on, you can just use shared library. Yeah, if your project is getting really huge, you can use versioning for your UI libraries. For example, you can be exposing, like as I showed, not like expose only one application. You can be exposing like version 1 module this or build this, version 2 module this, and so on. And in this way, you can expose your micro frontends can use this specific versions. And if your team, which is responsible for UI library, created some new version, yeah, previous version won't be broken. So something like this. Yeah, it's also quite, it will require some configuration, but it is really bug safe, let's say so.
Thanks. The next question. The first principle of micro frontend is be technology agnostic. How to combine different frameworks and versions of them in a single application?
Yeah, I believe I've just shared this example in single SPA. So you can just, single SPA doesn't care about the framework you're using. With the module federation, so honestly, initially I thought to add this example, but it doesn't really look good. So with module federation, yeah, it's possible. I can't say it's impossible, but if you use multi-frameworks, stick to single SPA, it will work better for you. So if you want me to share this example one more time, just give me a sec. I'll try to find this example, how it looks like. So yeah, like this. So this application will be loaded somewhere according to your URL, and inside of this application, you can do whatever you want. So it can be different frameworks, and single SPA doesn't care about the framework you're using.
Okay, let's move to the next question. What about routing? Do you have any issues?
Well, what I'm not sure I'm following which issues do you mean. So with the micro frontends, if you are talking about, let's try to split two approaches, a single SPA approach and module federation approach. So with single SPA, usually you are rendering entire route as, let's say, Angular or React application. And for example, for this dashboard will perhaps have its own implementation. Yep. For internal routing. For the same situation, for let's say we have an application for navbar, yeah, it will contain just general routes, so it won't be using like Angular router or React router. It will be using just plain anchor elements, and it might be not as convenient as we used to in our frameworks. If we talk about the module federation and React or Angular, well, they're pretty simple components. So consider them as a component. So can you have any components with and any issues with your components in your project? So probably not. So the same situation here. Yeah, so that's probably it.
Okay, thanks. If they are living in monorep, can they be just separate modules with their own visions?
With their own what? Sorry, can you please repeat?
Versions, I'm sorry, versions.
Yeah, sure. Well, that's also another. I was not going to cover this topic because, well, it's more related to monorepo than to microfrontends topic. But each monorepo provides its own techniques how to build and version the package. NX provided, turborepo provided, Lorna provided, and well, long story short, yes, you can do it. You can specify a version of your micro frontend to be used and so on, but you can just Google it. Really, it will be easier than. And for the sake of time, yeah, I'm not going to explain how exactly it's being done.
Thanks. I see you have a request to share the repo link. So I suppose we can share it in our email letter.
Yeah,
And
yeah.
we'll get it within like 24 hours.
Mm-hmm.
Okay, and the last question that we have is, what resources do you recommend to start learning micro frontends?
Sorry, can you say that again?
What resources do you recommend to start
Ah,
learning micro frontends?
well, what resources? I would actually recommend you to just opt to create your own pet project or try to clone this project and yeah, and just change something there just to see how it works. For example, use this link we're going to share. You open your framework, let's say for React or Angular, try to expose more modules, try to expose a table, yeah, let's say from another application and use it somewhere, and just try to play it in that way. Because basically theoretical part of the micro frontends is almost fully covered here. Yeah. If you want to dive into some specific details for your project, like performance optimization, like how exactly to render something in some specific case, how to version something, when it might be complicated thing, but I would just recommend it to you to play with it with your own in practice, let's say.
Okay, thanks. I see we have a new question. So, did you try to use ES modules instead of the federation?
No, honestly, I haven't tried.
Okay. I suppose we can wait for 1, 2 more minutes and see if anybody else has questions. So, yeah, as I mentioned previously, we will send all the details about the event, the link to repo and recording in a letter, so don't skip it. Sometimes it falls in spam folder, so check it out as well. Okay, we got one more question. So while we are answering that one, please, if somebody else has another questions, write them down, and we will go to them after that one. So the question, what about local development? If my microfrontend consumes components from other microfrontend, buttons, forms, and so on, do I need to run both microfrontends on my local machine?
Yeah, thank you for this question. So this is interesting topic. Theoretically, there are two ways to do it. If you want to keep ideal isolation, you can first of all pre-build this and serve it from your local machine to run only one microfrontend. But that's probably the best way if you are working on a really huge project and running a few microfrontend requires a lot of time. But if you go with this approach in 95% of the cases, I would just recommend you, just to run in two microfrontends or just to use a shared npm an npm package for this. Well, I've just provided this example. So you can use UI library as a microfrontend as a UI library, but that's really not necessary. You can just use your npm private package and use it with proper versioning. And you can just forget about the problems with running a few microfrontends.
Thank you for answer. Okay, I don't see any other questions, so I suppose we can finish our today's event. Thank you everyone who joined us today, and I hope that you get really valuable information for you. And thank you, Mikita, a lot about sharing your knowledge. It was very, very interesting.
Mm-hmm. Yep, thank you very much for joining, guys, and see you.
Yeah, join our other events and see you on the next webinar. Bye. Have a nice evening, all.
Yep, bye.